How many people have lived in something like this, spent the night in something like this, slept in a bed in a room in something like this? It's a house. And a lot of these houses have air conditioners. True? We should know. What is the number one question you're going to get after you get out of here, you pass your class, you have your degree? Friends will say, what type of things did you learn in your mechanical? Oh, I learned about thermodynamics. What type of things? I learned about refrigeration, air conditioning. Right then, you're going to feel a grip on your leg or your knee. They're going to grab onto you, and they're not going to let go until you answer their questions. They're going to drag you into their house and say, diagnose the problem, doctor. The air conditioning systems doesn't work, and somebody wants $3,000 or $5,000 to fix it, and I want you to help me. Make a good choice. This happens all the time. So anyway, let's have and discuss this system. What's sitting outside? Yeah, it's called the condensing unit. It has more than just a condensing coil. It has a compressor sitting there as well inside. We'll have a blow up of it next. But then you have lines that take something that runs in these lines, some fluid that runs in these lines, which connect it to a box that's either in the closet or in the attic, depending on where they put it in the house. And that sometimes is called a furnace. But they have some, but let's talk about what's running in this line. Do you think it might be refrigerant or air or water? It's refrigerant. It's refrigerant. And so it's circulating and going from the inside to the outside of the house. Now up in here, you have air that's taken, warm air that's taken inside the house, put through an air filter, put across a coil, is nice and cool, and put into a duct system, which then distributes it throughout different areas of the home and then puts it into your bedroom, into your living room, into your kitchen. So what's going in this duct system? Air, cool or conditioned air. It actually, in the wintertime, there'll be a propane, or not a propane. You could have propane, or you could have another natural gas furnace part of that to heat it up. And then you'd have warm air dumped into, or you could have electric resistive heat as well. Anyway, let's focus on air conditioning, making the air cold and dropping it into our house in the summer. So here's another blow up. This one shows you what the compressor looks like. And the condenser coil wraps around the side. Typically, they try and wrap it around as 100%, but they never really get 100%. Maybe they get 3 sides or 3.5 sides enclosed by that condenser coil. The fan on top turns on and throws air out. It draws the air in across the condenser coil and then rejects that heat to the air, throws it out top. You shouldn't use this as a table to put stuff. I've heard of lots of people. What did you find? Oh, I went to service it and they put bags of mulch on top of it. And then they wondered why the air conditioner didn't work. Well, they blocked it. And you shouldn't also, put plants and other things that grow right into it. It should have some airflow around it. Anyway, but that's the condensing unit. The fan makes a lot of noise, but the compressor makes a lot of noise as well. Then you have these lines in which the coolant, the refrigerant, flows. One flows in and one flows out. We'll get back to it in a second. Up here, it flows into essentially an expansion valve, which immediately is located very close to an evaporator coil. Now, this evaporator coil is shaped like this. They typically nickname it the A coil. I don't know where this part of the A comes from. It looks like upside down V coil, but nobody ever calls it the upside down V coil. They all call it the A coil. And this is your blower motor. The air comes in, goes across a filter. If you don't have a filter, get one, change it, make sure it's in good condition. Then it blows up and across this part of the coil and then continues in the ductwork. That's the evaporator coil. Why? Is the air that's flowing across that coil evaporating? Or is the refrigerant inside the coil evaporating? The refrigerant inside the coil. And if the refrigerant at low pressure is inside the coil evaporating, it's cold. And now the air flowing across it, the warm air gets colder. If you have humid air, like you live in Houston, guess what? Or even some days in San Antonio, you're going to have liquid water flowing down. That's why they slope this A coil like this. And it's going to collect in little trays on the edges, and you're going to have to do something with it. You're going to have to drain it out, so you have a condensate drain line that'll go out and dump. How many people remember? I do. You know, you're at your parents' house, you're 10 years old, you're walking around outside in the summer, you look, Dad, Mom, we got a problem. There's water dripping out over here. It's not a faucet, or at least I don't understand what's going on. Come look. It's the air conditioner system running. True? Remember that? Or you put it into the attic, you're the homeowner, and you say, there's nothing above me, there's not a toilet or a bathroom or a shower, and yet I have water dripping through my sheetrock. Anybody had that unpleasant experience? Me too. And that usually means that this line got clogged and it's going to overflow. And once it starts to overflow, it's going to go anywhere. Now, recently, maybe the last 20 years, they put alarm systems, they have backup, because it destroys a lot in a home. But an older system, maybe 30 years ago, it would just overflow. So that's one of the things that people come out and they'll drain and clear that line once a year as part of their maintenance agreement. Did you have a question? All right, let's keep going. So this is where the evaporator is. What's really close to the evaporator? The expansion valve. The expansion valve. So we have two components. The expansion valve and the evaporator, it's in the furnace inside your house or up in the attic or closet. The other two components, the compressor and the condenser, are outside. And the line set moves the coolant back and forth. Here's a close-up of that evaporator coil. They have a sheet metal blockage, and it forces the air that comes up to flow across like that. And you can see this little plastic tray with the drainage. And if you look close, you probably can see they have two holes. Kind of one a little higher, one a little lower. If the lower one fills up or plugs up, the second one will kick in, and there'll be a little sensor there that says, call your service technician right away because you're going to have problems. Well worth the investment, I think, when you install a new system. You have two lines which are connected to the evaporator coil. Those are those two long lines that come from all the way outside. Can you tell that one is a smaller diameter than the other? So one has smaller cross-sectional area. One of them is carrying liquid. One of them is carrying vapor. I don't know why they call one the liquid line and not this one the vapor line. That would make sense. Or, okay, if you're going to call it the suction line, then don't call this the liquid line, call it the push line. But they don't. All right? The liquid line, because of what's flowing in it, and the suction line, because what's on the other end pulling on it and sucking on it. The compressor sucking on it, that's what the compressor does, pulling. So now you can tell, first of all, this is the suction line. Which way is the refrigerant? Is it going in or away from? It's going away from, isn't it? It's going away from, and it's eventually going to go all the way down and go to the compressor, where the compressor, when it turns on, is sucking. Actually, the compressor, when it turns on, the inlet to the compressor pressure drops. That's why they call it sucking, because it's drawing it out, pushing it out. Okay, the liquid line, why do they call it liquid? Because it's liquid in it, and it's supplying, and so the smaller diameter is the liquid coming to the unit, which is both the expansion valve as well as the evaporator. This expansion valve has a lot of little nicknames. This one, TXV, thermostatic expansion valve. Typically what it does is have a little sensor, a bulb, to determine what is the temperature on that suction line. And if it's coming out too cold, then it says, I'm not going to give you enough refrigerant. You basically have put a lot of liquid in the evaporator, maybe close to flooding it. If it's too low, it's too high a temperature, then basically it's saying it's drying out that evaporator. Then this TXV will modulate and let more refrigerant flow into it. It's a control mechanism. And then what happens here, once it goes through the pressure drop, you distribute it to typically 3 or 4 or 6 sections that will go in different passageways through this heat exchanger and then get collected up in a manifold and then to the suction line. This is an expansion valve, thermostatic expansion valve. That's that bulb that you tape on so it can get a good temperature measurement on that suction line coming out of the evaporator. Some of them, old school, will have not a thermostatic expansion valve, but will just have what they call a capillary tube. It's a small tube. If it was straight, it would be very long, so they just coil it up, wrap it up into a circle. And that's what they're showing here. And it's high pressure on the inlet and low pressure on the outlet because engineers have spent a lot of time quantifying the characteristics. You can get a very good capillary tube. Capillary tubes are still used primarily in refrigerators. So if you take a look at your refrigerator at the house, you could probably easily find that capillary tube. All right, little quiz without the clickers. Where is the condenser? Let's just call it out. Is this it? Or is that it? Or that it? Or that it? Or that it? Where's the condenser? B, very good. Where is the evaporator? C. Where is the expansion valve? A little more tricky. C it is. And where's the compressor? B. What is A? The line set. All right. You have a large and a small diameter tube, copper tubes. Let's go. What is on the wall inside the living room or wherever they have it? It's a thermostat. And this is just some duct to distribute the air into the house. All right, we'll take a look at this one. Which line is short? This is a clicker question. Between the compressor and the condenser, between the compressor and the evaporator, condenser, expansion valve, and compressor. I'll give you a little extra time on this. The length of the line, which line is short of these 4? And some of them may not make sense. We're done? So in your mind, you're probably doing this very quickly. You have a compressor, you have a condenser, you have expansion valve, you have an evaporator, and refrigerant flows from the evaporator to the compressor, from the compressor to the condenser, from the condenser to the expansion valve, from the expansion valve to the evaporator. And we said 2 are typically inside the house and 2 outside. Which are the 2 outside? The compressor and the condenser are outside. And which 2 are inside? The expansion valve and the evaporator inside. All right. So is this line right here short or long? Short. This line, short or long? These 2 are the long lines, and this is the long line. And you could tell right away, one of the long lines was the suction line. This is the suction line down here, isn't it? And one was the liquid line. So let's just call it the liquid line. True? So they want to know which line is short. It'll be between the compressor and the condenser. That's a short line. It could also have the expansion valve and evaporator. Do we have expansion valve and evaporator? That would have been okay. True? The other ones, it don't make sense. Next question. Which line of these 4 is long? Everybody in? Sorry, oh man, I should have given more time, huh? So from the evaporator to the compressor, and that line is called the suction line. All right, which line is the liquid line? I already answered that one, right? Do you want it 30 seconds? Okay, 30 seconds. Which is the liquid line? They say to make really easy multiple choice questions, But even sometimes I made the question, I'll read it and be confused. Like, what? Did I even put the right answer up there? Anyway, that was good. So the liquid line, it's after the condensing coil or condenser and goes up to the expansion valve. Do you want to do this one? Which line is the suction line? Very good. So from the line that goes from the evaporator to the compressor's sucking on that line. All right. Guess what? There's no end to these things. There really isn't. All right. Which line transports the liquid? The small diameter or the large diameter line? Which line transports the liquid? The liquid is in the liquid line. Is it a small diameter line or a large diameter line? Somebody, either their friend is poking their keyboard on E, or they're just upset at me and don't want to participate. Either one, sorry. Let's not do a clicker on this one. Which line transports the vapor? It's got to be the large one. True? Now this one's really tough. I'm going to let you have it. Which line is cold to the touch? One will be warm, one will be cold. The small diameter, what was in the small diameter? Liquid. What was in the large diameter? Vapor. Which line is cold to the touch? Well, it's not unanimous, is it? There's a, 60, 34, 63, whatever, 66, 34 split. But this is a hard question. Let me ask this question. I'll grade this, but let me ask this question. The air that comes across this coil right here, maybe it comes in 75 degrees F and goes out maybe 55 degrees F, okay? What is the temperature of the refrigerant in that evaporator coil? Greater than 75 or less than 55? It's cold. It's less than 55. Now, if it's down around 32, you may get ice on that evaporator coil, and then it'll ice up, and if you have problems, they'll usually say, hey, and there's pictures on the internet of iced up evaporator coils. Not supposed to be that cold. All right. So the suction, after this, it's coming out vapor. Typically in our assumption, doesn't it come out saturated vapor? All right, the saturated vapor coming out of the evaporator coil, it's now going in the suction line down to the compressor. Is that saturated vapor hot or cold? It just came out of the evaporator. It just cooled down the air. I know, this is tricky. That's why I don't have 100% correct. The vapor coming out of the evaporator is cold. But that's just opposite. You think liquid cold, vapor hot. But it's low pressure. It's low pressure. So, which line is cold? Let me ask that question again. Only 30 seconds. With a little help of my friends, I can pass this class. There you go. All right. I don't know if I want to do this one. Okay, if that one was cold, guess what the other one is? Do you think it's warm? Actually, in the summer when it's been running constantly for a while, what's coming out, the liquid off of the condenser, guess what? You may not even be able to hold on to it for very long. It may burn you. It may be so hot. Think about this. The air, let's say you're running the air conditioner and it's 90 degrees outside. Do you think your air conditioning system should work or not work if it's 90 degrees outside? It should work. The refrigerant that's condensing has to be hotter than the air that it's rejecting heat to, maybe about 20, 25 degrees hotter. So let's at least put the refrigerant on a 90-degree day at the 110 degrees F. Does that make sense? All right, now it's 100 degrees F. Do you want your air conditioning system to work? 100 degree F day? All right, what's the refrigerant going to be condensing at? It's at least 25 or 20 degrees above the outdoor air temperature. It's now about 125 degrees F. All right. You want to, as an engineer, sell stuff that's going to work in New York, California, and Arizona. On the hottest day of New York, California, and hottest day of Arizona. Anybody seen the records of temperatures in Arizona? Let's say it's 1:30. You want to make sure your phone at your company's not ringing because your air conditioning system stopped working on the day that it's really needed in the really hot part of the United States. Does that make sense? All right, so we got 130 degree F air that you need to dump it to. Guess what your refrigerant's condensing at? 150, 160. You know, you got the picture. I can't write. I don't know why. It's hot. You touch it, guess what? It's liquid at that temperature. It's very surprising, isn't it? It's like, wow, the first time I understood this, right? Which is only a few hours ago. I only learned stuff right before the students. All right. Which line brings the refrigerant into the house? The small diameter liquid line? Does that the one bring it into the house? Or the large diameter suction line? Which one takes the refrigerant from the outside and brings it into the house? The other one's going to reverse it, but it's the liquid line. The liquid's now ready to go up to the expansion valve to drop the pressure to go into the evaporator. True? So the small diameter liquid line is what brings it into the house. I almost want to give up. They never end. Okay. Which line is typically insulated? Do you insulate the small diameter liquid line, or do you insulate the large diameter suction line? Which line do you typically insulate? This is a hard question. Take a guess. Because I got too much I got to cover. All right. Why do you insulate? To enhance heat transfer or to diminish heat transfer? Diminish heat transfer. That takes a while to understand. I insulate. Now, if I have a hot liquid line going up, if I cool the liquid a little more, it was just cooled to make it liquid coming out of the condenser. Is that going to be bad for performance or okay for performance? If the liquid line is hot and it's going to continue to reject a little heat as it goes up all the way to the attic before it gets to the expansion valve. As long as it's not going through my conditioned space, it's fine. Going through the attic and stuff. The suction line is cold, right? And it's now going down. If I have a heat transfer to it, what's going to happen to the refrigerant as it continues before it gets down to the compressor? It'll become more superheated. It came out maybe saturated vapor. Is that good for the compressor? Oh yeah, give me superheated vapor. No. Give me basically is the densest vapor you can. The compressor wants the densest vapor you can. Don't superheat it. It'll make my job harder as a compressor. So give me saturated vapor. So this added heat transfer is no good. There's other practical concern. If you're going through humid space where air is, guess what could form on the outside of that cool or cold large diameter suction line? Condensate, and you don't want condensate in a wall or anywhere else. It may drip. So, but that's a separate issue. But which line is typically insulated? Let's do it again. Which line do you typically insulate? The suction line, which is interesting. So you have a large diameter, and then you wrap a lot of insulation around it. It makes it a mammoth line compared to the little small line that's next to it. The liquid line is small diameter, never insulated. Never insulated. All right. But you may find for efficiency, they have mini split systems, and in the mini splits, they'll have different line sets that feed a line set to a particular room. Why? So that when you're not in this room, you can turn it off and save money. Yes?
Are they actually like a significant amount more efficient?
Well, it's like my car. I may only get 10 miles to the gallon when I'm driving it, but if I decide not to take it on my vacation, fair enough. If you turn it off, this is really good at saving money. Or if you let the temperature float up and you are over here, get it cool because I want comfort where I'm going to sleep or whatever.
But if you turn it off, wouldn't that room get hotter so you need more power to make it?
Press forward. Sometimes you'll see these. You don't see much of them. It's a packaged unit for a house. They don't put refrigerant in and out of the house. They put air in and out of the house. I've seen them. You can buy them, but I've not seen one in San Antonio, a packaged system. So the refrigerant stays only right there. There's no possibility of having a leak in a refrigerant line somewhere inside your house. Anybody seen the roof of a commercial building? Sometimes you're driving, you can see it on a hill looking down. You'll see a bunch of these sitting on the roof. Guess what? They're packaged rooftop units. And so they can blow the air right down into the building to cool it. And the refrigerant's contained right here. One can go out, the other can still work. The technician walks on the roof, services them. This is the way to go for commercial buildings.
How do they cool our campus?
Long story, and everybody's already packing up. Forget it, I give up. All right, I didn't make it as far as I wanted to. Test on Friday. Thank you for your attention. Great questions, sorry.